Okay, so MACC packets, we've got it filled out. If your parents sign it, bring it back to me, and then they'll be here Wednesday. So now, we used a lot of time to do that, but let's start some trig review. In calculus, it's not like we have whole sections of trig, but there are problems involving trig functions that pop up periodically. So we will encounter it frequently throughout the year. We make the assumption, unless we are specifically told otherwise, any trig function is going to be dealing with radians. Remember we talked about like radians are the real number measure, and so for us to be able to do calculus, it has to be in radian measure. So let's review first of all our unit circle. I'm going to tell you guys to fill this out and then put it in the front of your 3-ring binder, because every time we have something involving a trig function, if you tell me you don't remember, I'm going to tell you to pull out your trig review. So I will probably tell you to pull it out at some point. There's also some formulas attached on the second page. Remember we made that flip chart with all of our identities? So that paper that's stapled to it has some of the most important identities that we will be using. So this is your copy of them. Don't lose it. We'll use this paper all year long. So let's run through our unit circle. Even though we're going to do radians, let's go ahead and mark our degree measures just as a good refresher. So we have 0. What were our fingers?
30, 45, 60, 90.
Okay, then remember we jumped all the way down here.
270. Oh, right.
And then we subtract our reference angle. So 180 minus 30. 180 minus 45. 180 minus 60. Third quadrant, add your reference angle. So 180 plus 30.
Okay.
180 plus 45. 180 plus 60. 180 plus 90. And then how do we get them in the last?
Subtract 360
minus. So 360 minus 30. 360 minus 45. 360 minus 60. Now we do our radian measures. So 0 degrees is the same as 0 radians. 360 is the same as what? 2 pi. So you can call it 0, you could say 2 pi if you wanted. They're the same. Okay, 30 is pi over 6. 45 is pi over 4. 60 pi over 90 pi over 2. Jump down to 180, that's pi. And then what's the pattern in the second quadrant?
Which one?
So we're subtracting, it's like pi minus each of these, so it's 1 less. So we get 5 pi over 6, 3 pi over 4, 2 pi over 3. Remember, the denominators match, so everything with that has a reference angle of 30 will be over 6. Everything that has a reference angle of 45 will be over 4. Everything with a reference angle of 60 is over 3. All right, third quadrant, you're doing pi plus each of these. so the top is one higher. So 7 pi over 6, 5 pi over 4, 4 pi over 3.
There's definitely a 9.
It wasn't. I'm telling you, it takes me a little bit to start writing these with my slate again. Alright, in this, we're subtracting from 2 pi, so it's double minus 1. So 11 pi over 6,
Oh, yes.
7 pi over 4, 5 pi over 3. Okay. So far, so good.
These red peppers really hitting this.
Then, what else do we have on our unit circle?
Or pears.
Ordered pairs. So remember, in those ordered pairs, the x is the cosine, y is the sine. So at 0, think about your hand trick. Cosine of 0 is
0.
no.
Well, it's 2, 1. Wait.
Cosine is it's undefined,
No?
right?
Well, it's square root bottom over 2, which would just be 1.
So remember hand trick.
Oh.
You fold your finger. Sine is the square root of the top over 2. Cosine is the square root of the bottom over 2. So square root of 4 over 2. 2 over 2 is 1. Sine, we have 0 fingers above, so square root of 0 divided by 2 is 0. And that should make sense. If this is an xy grid, it's saying that 0, 0. This should be the point 1, 0. What's this point?
0, 1.
What's this one?
Negative 1, 0.
And what's this one?
0, 1.
Okay. 30. So if you fold in your 30, cosine is the square root of the bottom over 2, so radical 3 over 2. Sine, square root of the top over 2, so square root of 1 over 2 is 1 half.
Oh, why did I do it like that? I wrote it as a fraction. All of it.
I mean, just be able to do like your hand trick.
Cosine.
We want to remember all of
No, I'm never going to tell you to fill out a unit
what,
circle.
because I forgot how to do that.
Cosine?
Cosine.
It's written up in the top
Oh,
right
yeah,
corner.
because cosine is x over.
You can't see? Okay, so 45, square root of the bottom.
2.
So square root of 2 over 2. Top. Square root of 2 over 2. Okay, 60. Cosine, the bottom, radical 1 over 2. 1 half. Sine is the top, square root of 3 over 2. Alright, at this point, then the rest of them, we just think about the quadrants. If you are in the second quadrant, what would be true?
Negative.
X is negative. So you use the same order pairs for your reference angles, but the x is negative. Negative radical 3 over 2, 1 half. Negative radical 2 over 2. Positive radical 2 over 2. 1 half. What about the third quadrant?
And y is negative.
Just y?
No, they're both negative, sorry.
And in the fourth quadrant.
The y.
So just remember your reference angle is the same points, the only thing that changes is positive or negative. go ahead and do the back. We're going to fill in the graphs. So we're kind of putting all of our important information on here that you might need to reference throughout the year. Sine, we just got done graphing. These points on the x-axis are the angles. So we had 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, if you're thinking about your y values, your highest y value is and your lowest. Okay. What is the sine of 0? Is
Sine
Zero.
starts low, cosine starts
sine of pi over 2, or the sine of 90. The sine of pi, if you're looking at your unit circle, these are your y values. 3 pi over 2. 2 pi. Remember, when you graph this, it is a curve, it's not a zigzag.
Can you draw it as continuous or?
I mean, yes, you should recognize that it keeps going. What? The x-axis points or the? They are. Right, cosine. So again, 1, -1, points on the x-axis, pi over 2, pi, pi over 2, and 2 pi. All right, what's the cosine of 0?
1.
Yeah, think about your unit circle. If you look at these points, cosine's the x value. So at pi over 2 on your unit circle, the x value was,
0.
and then at pi, your x value is 3 pi over 2 and 2 pi.
I don't actually know how we're figuring this out. I just remember how they work. So,
Sequence off the unit circle.
yeah, but I don't know how they're we're showing that they're going up and down.
So it's just like plotting the x's. So 1,
Oh,
0, -1, 0.
I just remembered how we did it.
Tangent. We plotted that one weird because of asymptotes. We went from negative pi over 2 to positive pi over 2. So halfway in between, if this was 0, this would be negative pi over 4, positive pi over 4. And these are -1 and are 1. So, tangent is 0. If you think about 0, tangent, sine over cosine. So square root of the top over square root of the bottom. So square root of 0 over the square root of 4 is 0. If you did pi over 4, 45. Radical 2 over radical 2 is 1. At pi over 2, square root of 4 over the square root of 0, that's undefined, so that's an asymptote.
Oh, yeah.
At negative pi over 4, that's the fourth quadrant, tangent's a -1. Negative pi over 2 is undefined. And then we have this nice curve approaching our asymptote. Cotangent, we also do different intervals. This one we went 0 to pi. So 0, pi over 4, pi over 2, 3 pi over 4, and pi. Cotangent is cosine over sine. So it'd be the square root of the bottom over the square root of the top. So radical 4 over 0, undefined. Okay, at pi over 4, 45. Radical 2 over radical 2 is 1. Pi over 2 at 90. It'd be the square root of 0 over the square root of 4. 3 pi over 4, that's in the second quadrant, so it will be a negative 1. And pi is 0. So this is like tangent.
Oh, it goes back up? Pi is undefined?
Mm-hmm.
Okay.
Yeah, we picked tangent, cotangent intervals so that we had our asymptotes at both ends.
You said pi is 0. That's why I was
Oh,
confused.
sorry. I meant
I believe you.
okay. Secant is the reciprocal of what? Cosine. So we think about cosine for a minute. Okay, and what we usually did is lightly drew in cosine. So cosine of 0, we already drew the cosine, that was 1. Pi over 2 is at 0, pi negative 1. 3 pi over 2, 0, 2 pi is 1. So this is our cosine graph. Now that's not my final answer, but this is what we use to help us get it. And so then,
You were at 0, so you have 0.
anyway, 0, we get a vertical asymptote. High and low points stay.
This is sad.
Sad.
I don't know why, but that really helped me remember it so much.
Funny.
And only sad clown if you draw the graph under it. Or else if you don't draw like the original graph.
Then it doesn't look sad. Okay, and cosecant is the reciprocal of
Sine.
sine.
It still looks sad. It just doesn't look like a clown.
So we think about sine of 0 is 0. Pi over 2 is 1. Pi is 0. 3 pi over 2 negative 1. 2 pi is 0. Then asymptotes where it was 0. High and low points stay. And it looks like that.
I think you need the NHS colors.
Yeah.
Ooh.
Alright, so there's like 2.5 chapters of trig in 20 minutes.
We're gonna have to do trivia someday.
Alright, are there questions on that?
Those are the ones that sucked whenever we first got into them, because you had to go from one thing to another thing. So, it was
Y'all about to catch me getting my flipbook back out.
Okay,
I kept it.
let's do.
It's not the flipbook now.
Okay. This you'll have to do in your notes. I did not print everything.
What?
I know. Sorry. This is your reference page, all the stuff you want to keep.
Oh, is this our homework?
Nope.
Oh, okay. Do we have homework? Let me hand out.
Alright. So our definitions. What's the definition of sine?
Square root of the bottom over square root of the top.
Y over x. If you're thinking about SOHCAHTOA, you can think opposite over hypotenuse. We defined it both ways. And cosecant is the reciprocal. X over y or hypotenuse.
Isn't it R?
Oops, why did I put y over x? I was doing tangent.
Because we let you.
Yeah. See, you guys are supposed to stop me.
Sorry.
Y over r. R is a hypotenuse.
This will be the only thing I remember now. When we you get to the test, like I will only remember y over x.
That's tangent. Okay, cosine is
X over r.
x over r.
Or, adjacent over r.
Okay, secant is the reciprocal, so r over x or hypotenuse over adjacent. And tangent.
I think it's y over x.
You think so?
I hope so.
Just potential.
So opposite over adjacent, and then cotangent is flipped. All right. Let's do some examples then. I ended up taking most of the more today. Okay, so we should be able to go back and forth between degrees and radians. If I told you, so we're doing this in our notes, what is 210 degrees in radians? What would we do?
Take
The job calculator.
Because think about on your unit circle, pi and 180 are at the same spot, they're equivalent. Then our degrees cancel, 210 over 180 reduces to,
Probably 7/6.
I think so.
Yes.
If I could get the thing off my calculator, I would tell you.
Negative 122 degrees. Does it matter that it's negative? Nope. Same thing. Multiply by pi over 180. Degrees cancel. 122 over 180 reduces to,
61 over
so negative 61 pi over 9.
Oh, I wrote degrees in my comment because I just heard it like
Let's go the other way.
it's not in the comment. I'm giving it to you. You got multiplied by 180 over time.
Yes. If I want to go the other direction. Oh, that's what I grabbed for you.
Oh, different.
Yeah, seriously. I am that good. I'm a mind reader. So we multiply by pi's cancel, so 11 times 180 divided by 5. 396, you said? Okay, 2 pi over 3 times 180 over pi. Pi's drop. 120
And that's one of the ones on our circle, right?
degrees. Mm-hmm.
Okay. It sounded real familiar.
Should be familiar.
Sometimes, but then it's like 125 or something. I'm like 120.
Alright, let's do, by our last slide for today. Evaluating these. Do you remember the two pieces of information I want you to write down every time? Quadrant, reference.
That was only if we got it wrong.
5 pi over 6 is in what quadrant?
That would be the sixth.
Okay. Radians reference angle is easy, it's just pi over your denominator, so it's pi over 6. So in the second quadrant, is cosine positive or negative? Remember, all students take calculus, so it would be negative. And then we think cosine of pi over 6 is cosine of 30 degrees. Okay, hand. So pi over 6 is like 30 degrees. Cosine at the bottom, radical 3 over 2.
Pi and stuff.
I know, the pi's are a little trickier. Think about pi is here, What's that ordered pair on the unit circle?
-1, 0.
Okay, so we know sine is the reciprocal cosecant. Sine is 0, so cosecant is,
Sine of 0 is
That's undefined.
undefined.
Oh, yeah.
If we know it's gonna be undefined, do we need to write the quadrant and represent it?
No,
It'll
I
only
mean-
be undefined on a line.
yeah, so there really isn't a quadrant.
It's really just a suggestion.
Is it though? Alright, -7/4. What do we do when we have negatives?
Gotta add 2 pi.
So 2 pi is like 8/4 plus -7/4 is 1/4. So that's just pi over 4, 45 degrees, sine is. Alright, last problem of the day. What quadrant is 7 pi over 6 in? Reference angle, pi over 6 in. Quadrant 3. Take tangents positive, which means cotangent would also be positive. Okay, pi over 6 is 30 degrees. So tangent, square root of 1 over square root of 3, but cotangent flips it, so radical 3 over radical 1. Which part? The positive? Do we know why it's positive?
Because it's also take count.
Okay, so pi over 6 is 30 degrees. Okay. Tangent is sine over cosine, so square root of the top over square root of the bottom. Okay, so radical 1 over radical 3. But cotangent flips it, so radical 3 over radical 1. Tomorrow, we're going to do some more practice with all this stuff. So, like, if you look back at your notes handout, I have some more sample ones we're going to do. And we're also going to do a little bit with identities. Okay? I don't have too much left. I will go ahead and give you the handout for this section, but it won't be due until Tuesday because we don't have school Monday. So we'll finish this tomorrow.